Okay, kids, we are starting lesson 1-3 today. The good news is there is almost nothing new in chapter 1. I hope y'all remember me telling y'all last quarter that this quarter was going to be a hodgepodge of review work. Sometimes it'd be you'd learn nothing new today. Sometimes you'd learn, oh yeah, I forgot that. And then sometimes there'd be something new. But chapter 1, it's a great chapter to do online. Because there is literally nothing like that you didn't learn in Algebra 1 or in Algebra 2. Now, you may have forgotten a few things, but it's still a pretty easy chapter. So let's jump into increasing and decreasing and constant. So functions are increasing when the slopes are positive. Functions are decreasing when the slopes are negative. So hopefully you remember that when things lean to the right, that has a positive slope, and so therefore that function would be increasing. And when the line slopes to the left, leans to the left, not slopes to the left, leans to the left, it has a negative. So there's two really important things you need to remember about increasing, decreasing, especially when it comes to my math lab. Two really important details. Detail number one is always use parentheses, never brackets. And detail number two is that we are always talking about the x values, never the y values, always the x values. So I went ahead and I labeled that point right there, -1, 4. So you can see it's increasing from negative infinity to -1. So notice I use a parentheses and I'm only using the x value. It's decreasing from -1 to infinity, and there are no times when that function is constant. Okay, so let's go look at this second picture. So this is the origin 0, 0. So it is increasing from 0 to infinity. Notice I use a parentheses. There's no place where it's decreasing, and it's constant from -infinity to 0. Okay, now let's do one that has a couple of different things. So again, I've labeled some points. This is the point 0, 0. This is the point 2, 4. This is the point 3, 0, which 3, 0 really isn't a meaningful point for increasing, decreasing. So here, it is decreasing. So it is decreasing from -infinity to 0. Oh, decreasing, -infinity to 0. Then it's increasing from 0 to 2. Notice I'm using parentheses. And then it's decreasing from 2 to infinity. So another thing that you will need to watch my math lab about is sometimes they say use a comma to separate, and then if they don't say use a comma, then you'll need to use the union symbol. Okay, so another vocabulary word we need to learn are something called relative minimums and relative maximas. They're points at which the function changes from increasing, decreasing. They're often also called local maximums and local minimums because it's like this point isn't actually the maximum of the graph. You can see the graph goes up and up, but we call it a relative maximum or a local maximum. So this is a relative minimum. This is a relative maximum. Super important in calculus. You're going to find out about what happens at the derivative right there. This is very important for your foundation in calculus. Not hard, but important. Okay, so let's kind of talk through this back page. So it says, sorry, cleaning the screen a little bit. What's going on here? It looks a little blurry to me. There we go. Okay, it says find the number, if any, at which f has a relative maximum. What are the relative maximums? And find the number, if any, of which f has a relative minimum. What are the relative minimums? So this spot is a relative maximum, and I've labeled that point -1, 3. This point is a relative minimum. I think I said that backwards, y'all. I'm sorry. I'm still on spring break. This is a relative minimum, and its ordered pair is -1, 3. This is a relative maximum, and I've labeled it as 0, 4, and that is a local minimum or a relative minimum, and it is the point 2, -3. So f of x has a relative maximum at x equals 0, and so f of 0 equals 4. F of x has two relative minimums at x equaling -1 and at x equals positive 2. So we say f of -1 is 3 and f of 2 is -3. All right, so another thing we're going to talk about are something called odd and even functions. So an odd function, well, I'll start with an even function. An even function is a function that you can plug -x in, and if you get exactly the same thing back that you started with, it's an even function. If you plug -x in and you get the exact opposite thing back, it's an odd function. And if you get anything else, it's neither. Now, again, this might sound a little bit more confusing than it actually is, but all you do is every place there is an x, you plug in a -x in parentheses. So there's an x, so I put a -x and I cubed it, and then minus, and then there's an x. So what happens when you cube -x cubed is you get -x cubed, and then that becomes positive x. So if it's exactly the same, it's even. If it's exactly opposite, it's odd. So look, it is exactly the opposite. So this guy is an odd function. All right, so now we're going to do that again. Every place there's an x, we're going to plug in a -x. So -x to the 6th power in parentheses minus -x in parentheses to the 4th minus 2. So when you raise this negative sign to the 6th power, it's going to become, or I guess it's going to stay, x to the 6th. And then minus, and that's going to become x to the 4th minus 2. So look at the original function. Look at what happened when we plugged in -x. It stayed exactly the same. So we call that an even function. All right, let's do one more of these. Every place there was an x, I'm plugging in -x. So -x to the 5th power is -x to the 5th. And then -x cubed is negative times a negative, so that's going to become positive 7x cubed. That's going to become positive 8x, and that's going to become -7. Now, if you're not careful here, you might think this is an odd function, but because that's the opposite sign, that's the opposite sign, that's the opposite sign, that's not the opposite sign, so this guy is neither. All right, video 1 done.